Let us see how to sketch graph of a polynomial function. Function given to us is f of x equals to minus x times x minus 1 whole cube times x plus 3 whole square. Now in this particular video, we'll concentrate on the behavior of polynomial function near its x-intercept. So that will help us to sketch even better graphs for polynomials. Now let's look into different aspects which should help us to sketch this graph as best as we can. One is that we should know the end behavior, and to find the end behavior we need to know two things. One is degree and the other one is leading coefficient, right? So we are trying to analyze the end behavior of our function, right? That is the first part. So end behavior comes from degree. Degree of this function is how much? 2 plus 3, 5, 5 plus 1, 6. So basically it's an even degree function. And how about the leading coefficient? Now leading coefficient is what? Minus 1, right? This is minus. So when you multiply all these x's, you'll get x cubed here, x squared here, and minus x. So it'll be minus x to the power of 6. So the leading coefficient is negative. Now if you have degree which is even and leading coefficient which is negative, you know what the end behavior is, correct? So we'll keep that end behavior in mind and then we'll sketch the graph. Now can you tell me what is the end behavior? Now in this case, if x approaches negative infinity, y should approach what? And if x approaches positive infinity, y should approach what? That is what we're trying to figure out. Well, since the function is even, leading coefficient is negative. Negative means right side down and even means both face on the same side. So we have kind of like this situation. Do you see that? So the graph should be starting from quadrant 3 and should end in quadrant 4. So that is what we expect. So this is kind of very important to understand before we sketch the graph. The second point which is most important for us here is the zeros of the function, right? Now zeros for this, let's say real zeros are the x-intercepts. Now those x-intercepts are at x equals to 0, at 1, and at minus 3. So we got 3 x-intercepts which we can plot on the graph. Let's say the first one is 0 and then we have at 1 and then minus 3. So let's say this is 1 and this is 2 and this will be minus 3 for us. So these are the 3 zeros for us. In zeros, it is kind of important for us to write down the order of 0. Now many students don't really get into that detail. Order of 0 makes 0 different from x-intercepts. X-intercepts are the points where the graph intercepts x-axis. That's it. Zeros have an order which decide behavior of the polynomial function at the x-intercept. And you will notice I have taken these 3 zeros which are of different kind. The first one is linear, the second one is cubic, and then we have a square, right, like a parabola. So the order decides the behavior, and in this graph I will show you how exactly. So first 0, which is at x equals to 0, is actually linear in nature. So its order is 1, we say. Now the second one, which is at x equals to 1, its order is 3. So it's kind of cubic, right? And the third one has order of 2, right? Now, so when we say it's a linear 0, that means it will cross the line, cross the x-axis like a line. When we say that the order is 3, then it is going to cross, or rather at x-intercept, it will behave like a cubic curve, right? So like this. Do you understand? And here, when we say it is of order 2, it has to turn, it will not cross. Like the vertex of a parabola. That's how it is going to be. So let's look into all these zeros one by one. So the first one which we are talking about is at minus 3. So this is my first 0 at minus 3. So at minus 3, the order is 2. That means at this point the graph will turn, do you understand? Like a parabola. That's what I mean when I say that the 0 has the order of 2. The next one, which is right there, is at, well, which is right there in the center, is at 0 and the order is 1, right? Order 1 means it is going to cross. Now since we are in quadrant 3 and we have to cross, it will cross from here to here like a straight line. And the third 0 is at plus 1, right? Now here for plus 1 the order is cubic. Since it's cubic, it will kind of go like this and behave like a cubic function. Do you see that? That tilde type of a sign will come. Now what we know here is we have these three zeros. One is at minus 3, the other one is at 0, and then we have at 1. Now y-intercept for us is at the origin itself. Combining these points with a smooth curve should give us the sketch of a graph of polynomial function we are looking for, right? So let's do it. So we'll just extend these things. We know that's kind of like this. Do you see that? Going towards minus infinity. Here we'll take it up from here and connect it with this line, right? And then we know it crosses like a line and it has to turn back to come back to the 0. There you are, and then here it will go like this. That's it. So what we get here is the polynomial function f of x equals to minus x times x minus 1 whole cube times x plus 3 whole square. Well, that's it. So to summarize, look into the polynomial function and understand its characteristics. Most important is end behavior, which you get from degree and leading coefficient. Then plot your zeros, figure out their order, mark the characteristics on the graph as I did, right? These are all markings which help me to sketch the graph of a polynomial function, right? So once you do that, connect the points with a smooth curve. That's it. I hope you enjoy it. Thank you and all the best.